Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Good evening, everyone. I hope I am properly audible and visible. And I would request all of you to kindly do a +1 in the chat box so that I could get to know your names. And at the same time, kindly give me a just tell me that I'm properly audible and visible. Okay. So, hi, Rishit. Yeah, I would request, just like Rishit, to everyone to please write a +1 in the chat box so that I could get to know your names, and at the same time, this would be interactive as well. Okay. Yeah, then that's great. Okay, so before I begin, let me give you a small introduction about this series, and then we can very quickly start with the problems. So we are having a series called Practice Session for SDE Interviews, and in this series, basically we take up important topics which are very important from interview point of view, and then we discuss important questions and problems related to those. So this week we are starting with dynamic programming, and previously we have already covered topics like binary search, stacks and queues. Then we studied about mathematics and bits manipulation, and in the previous week we studied about recursion and backtracking also. So this week we will be majorly focusing on dynamic programming. Okay, and since dynamic programming is always a very favorite and hot topic for the interviewers, so I hope this session will definitely be helpful for you all. Okay, so let me share my screen and then we can start with the session. We have already quite a lot of audience today. I would really thank everyone for coming. Okay, hello Hassan Nihal, hello Mustafizur. Let me just share my screen very quickly. Just a minute. Yeah. So I will be sharing my Microsoft Whiteboard screen. Okay. So I hope everyone is able to see it properly. Okay. So let me change the layout as well. Yeah. So ये GFG की वेबसाइट गलत टाइम बता रही है इवेंट का. What is it showing? Which event are you talking about? Aman Mishra, I can think about the recursive approach but can't find a recurrence relation. Okay, yeah. So I will be discussing a few boilerplate steps that you can basically adopt, and that will certainly be helpful for you when you are dealing with recursion. Okay. So today I think we will be discussing around 2 to 3 problems, and the session will be around 40 minutes long and 40 to 50 minutes at max. And I would request everyone to kindly keep this session as interactive as possible. Okay, so that it becomes an enjoyable experience for you as well and for me as well. So, do you want a black background or a white one? I usually prefer black, so let's keep it black. Okay. Hmm. So, Aman, you're talking about which event? Okay, so let's move. Hmm. So, in case if you are in your second years or in your third years and you are going to have your upcoming interviews for your internships or placements, so in that case, I would recommend you all to kindly check out a course called Complete Interview Preparation by Geeks for Geeks. So you can find that particular link in the comment and as well as in the description of this particular stream. So that particular course is an extremely well crafted course, and it contains everything in a very structured fashion. So if you are preparing for your interview, I can guarantee you that it will be most certainly be helpful for your preparation. Okay, so let us move to the topic. Okay, Okay, I think it was by mistakenly scheduled at 9 p.m. So basically, it was initially at 9 p.m. So basically, what I'm trying to do here is that I'm getting to know that at which particular time, whether it is 9 p.m. or 10 p.m., I can find maximum number of audiences. So that is the reason I changed it to 10 p.m. before the event. Okay, so but I see that the students that who are coming regularly at 9 p.m. also are definitely coming at 10 p.m. also. Anyway, let's proceed. So Vaibhav is saying is math very required for DP? Not necessarily, but mathematics is definitely required for data structure and algorithm. So if you have a good grasp on maths, you will certainly find everything easy. Okay. So can anyone please tell me what exactly is a dynamic programming and why do we need it? Okay. And why do we need it? Just a small brief introduction and then we can move to problem. Why greedy approach is not sufficient? And in which of the case, like whether greedy approach or dynamic programming approach, time complexity is more in which case? Hmm. So okay, so tell me, the time complexity is more in which case? Okay, just tell me this and also tell me different types of dynamic programming approaches. So okay, what are the different types of dynamic programming approaches? So I hope you guys know about this. Okay, so reduce calculations is math. Okay, tell me more. Yeah, definitely it reduces calculation. Okay, so but let me give you a small idea that let's say if there is a problem which you can basically do in O of n time, okay, through greedy approach, but it may happen that doing in that approach is giving a wrong result. So in that case, what you are doing basically trying out dynamic programming. So once you're trying out dynamic programming, what happens here is that let's say you've got a problem and the greedy approach is failing. So when a greedy approach is failing, it means that you cannot apply the concept of greedy in that problem. So what you do instead of trying to apply the greedy approach, you try all possible ways a given problem can be solved. So basically, it means that you are not greedily choosing any particular solution. In fact, you are checking each and every solution. So the time complexity in that case becomes exponential because you are trying to check each and every possible solution. But what TP does here is that it memorizes basically all the recursive solutions that you are particularly visiting. And in that case, what you can do, if you have already calculated a particular answer, and when you are calculating a new answer which requires the previous answer, instead of recalculating it again, what you will do, you will just take up that particular stored answer. So that is the entire approach of dynamic programming. Okay, yeah, we check all possible ways. Okay, so checking of all possible ways is basically not a greedy method. It is basically a brute force method, checking all possible ways. Okay, so but checking all possible ways is a costly operation, and you don't want that. So instead, what you can do here is that you will apply the concept of dynamic programming to when you have to check all possible cases. Okay, now let's say I give you a very small, very easy problem. I say you that I give you 10 coins numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I tell you that pick 5 points such that the sum is maximum. So in that case, what will you do? It's a very easy problem. Okay, like just a common sense problem. Okay, so let's say I give you 10 points. Okay, so 10 points from 1 to 10. And I tell you to pick 5 points such that the sum is maximum. Okay, so what will you do? Anyone? It's a very common sense problem to avoid overlapping subproblem. Yes, exactly, Vaibhav. So these are technical terms. We will be coming when we are solving the problem. But just to start with the basic motivation, I'm discussing this. So tell me this. So I give you 10 coins and you're asked to pick up 5 points such that the sum is maximum. So in that case, basically, without thinking anything, just like common sense, you will say that you will pick the 5 most maximum value points. That is 10 plus 9 plus 8 plus 7 plus 6. This is basically common sense. Okay. So 10 plus 9 plus 8 plus 7 plus 6. So this greedy method is basically taking a linear time. Okay. So now, if I would have told you, let's say I give this problem to a person who doesn't have common sense. So what will he do? He will try out all possible 5 coins which are possible. Okay, so there are 10 possibilities. So he will do 10C5 combinations. So he will basically check out the sum of all possible combinations that you can make through 10 coins, picking 5 at a time. So basically what is happening here, he will do NC5. Okay. So in this case, this will basically be like factorial complexity, right? Because you write n, this is basically n factorial divided by n minus 5 factorial divided by 5 factorial. So this will basically an expensive computation. But since a person has common sense, he's applying greedy strategy, and instead of doing all this thing, he's just taking it, sorting the coins and taking the maximum 5 values. Okay. So now there are certain problems in which such greedy approach, such intuition doesn't work, because you think that this type of intuition may work, but actually the answer is wrong, because just thinking greedily will not give you the answer. So in those cases, you have to try out all possible solutions. Okay, but at the same time, you have to make sure that they are not computationally expensive. Okay, so writing a brute force and checking out all possible solution is very computationally expensive. So that is where dynamic programming comes in. Okay, I hope this is clear. Okay, so before I proceed further, let me give you a small introduction about myself. So let me just write it here about myself. Hmm. So my name is Gaurav Kumar Shah. So I'm writing my name here. Uh, so whiteboard issues. So my name is Gaurav Kumar Shah, and I am presently in my third year. Almost my third year is about to end in a few months, or in fact, 1 month to be precise, at IIT Kharagpur. Okay, and I'm also a mentor at GeeksforGeeks for the past 7 to 8 months. Okay, and I have a really good history of mentoring and teaching students and preparing themselves for them for interviews. And I'm also an incoming SDE intern at CureFit. Okay, so this is about myself. So let's move to the problems. So the first problem that we will do is a very simple problem, which is basically the Fibonacci number. Okay, so let's see. I hope everyone has done the problems related to climbing stairs problem. Can I please have a +1 in the chat? Yeah, thank you, Abhijit. Thank you, Naikaj. Okay, so the first problem that we will do basically is the most easiest problem of dynamic programming. It is basically a 1D problem. Okay, but the second and third problem will be a tougher. Okay, okay, so let's see a climbing stairs problem. So I hope everyone can write the recurrence relation. So let me give you a small idea about how DP are formed. So in DP, what we do basically, we try to write a brute force recursion. Okay, and then we try to memorize that recursion. Okay, so as to make it a time complexity, we should to make the time complexity to reduce the time complexity. This is one way of solving a dynamic programming problem. Second way is that once you write a brute force recursion and memorize it, you can basically make a tabulation as well. Okay, tabulation as well. So recursion basically takes a recursion stack space. Okay, and tabulation doesn't require any extra recursion stack space in the computer memory. So in that case, this is a little bit space optimized version. Okay, so this is what the two types of dynamic programming are. Okay, so basically whenever you have a problem and you are required to write a dynamic programming solution, the first step would be to write a brute force recursion. Okay, brute force recursion to solve the problem. Okay, and once you've written a brute force recursion, try to memorize that one particular. And before you do step 1 and step 2, make sure that you have overlapping subproblems. Okay, if there may be problems in which you are not able to find overlapping subproblems, so in that case, you certainly cannot apply dynamic programming. I will show you how exactly overlapping subproblems are identified. Okay, so the very first problem, which is very easy problem actually. So in that problem, you will get to know this. Okay, so let's see then. Just a minute. Let the notes. Let's yeah. So let's say you are given a number of stairs starting from the 0th stair. You need to climb to the nth stair. So let's say this is a 0th stair. Okay. So 0, 1, 2, 3. Okay. This is 0, this is 1, this is 2, and this is 3. So from 0 you will go to 1, from 1 you will go to 2, and from 2 you will go to 3. Okay, so at a time we can climb either 1 or the 2 steps. So you can either go from 0 to 1 or 0 to 2. So 1, so basically possible choice of movement are 1 and 2. Okay, so 1 and 2. So these are the possible choices of movement that you can have to start. Now you have to write the total number of distinct ways you can reach from 0th to nth stairs. So total ways you can reach from 0th to nth stairs. Okay, nth stair. How will you write? Tell me. So first tell me, why is it a DP problem? Why is it a DP problem? The first step. Because recursion, memorization, all are secondary things. First you have to identify that there are overlapping sub-problems or not. How will you identify this? Can anyone in the chat box tell me? Anyone? Yeah. Rishit, can you tell me why exactly there we have an overlapping sub-problem in this case, and why can we apply the dynamic programming? Yeah, Rishit, you can tell me. Yeah, so there are scenarios that are repeating as in we can arrive at a same step from multiple previous steps. Exactly, Rishit. Rishit. This is the best answer. That let's say you're standing at any particular stair number, so you have reached that particular stair number from any of the previous stairs. So it may happen the way that you have reached that particular stair number are repeating, but we know the solution from a given step is no, so we can reuse it. Yes. So if you're sure that you have arrived at stair number 100 by through stair number 98, and if you know that all the ways you arrived at stair number 98, so basically you can reuse those solutions to calculate the number of ways to arrive at stair number 100. Okay, so this is the intuition behind why it is an overlapping subproblem. Now I will write basically the recurrence relation now, and what exactly is the recurrence relation. So let's say I'm trying to formulate a recursive solution to this problem. So let's say I have a function. Okay. So I have a function f which accepts a parameter called index. Okay. So initially the index will be 0. Now what will I do here is that so no, initially let's say this is the 0th index, this is stair 1, stair 2, and we have stair n. So let's say you're standing at stair number n. So if you're standing at stair number n, because this is the final state. Okay, so this is the final state, and you are supposed to reach here. So let us say that we start our recurrence relation from stair number n. Now, what are the ways in which we could have reached stair number n? So stair number n could have been reached through stair number n minus 1 and n minus 2, because in the question it is already mentioned that you can only take one step at a time or two step at a time. So it certainly makes sense that you have reached stair number n through stair number n minus 1 or stair number n minus 2. Okay, so basically what we will do here is that the total number of ways in which you have reached stair number 1, stair number n minus 1, and the total number of ways you have reached the stair number n minus 2 will be your answer for stair number n. So what you will do? You will just return this value. So return answer, which will be equal to f of int minus 1 plus f of int minus 2. So this is a recursive relation, and this is also a recursive relation. Okay. So let's say I'm trying to find the first stair number 5. So 5 will recursively call 4 and 3. 4 will recursively call 3 and 2. 3 will recursively call 3, 2 and 1. Okay, so you see that this recursion call for 3, this recursion call for 3 are basically repeating. So once we have recursively called for these 3, I can store the value. And whenever I am required to call the value of 3 again, instead of calling recursion, I will just utilize that value. So that is the idea of dynamic programming. Okay. So now I will call the recursion. But you know that in order to stop a recursion, you need to have base cases. So can anyone tell me what are the base cases in this case? Anyone? Rishit, Abhijit? Yeah. So the students who have joined late, I would request you all to kindly interact in the chat box, and you can do a +1 in the chat as well. Apart from that, if you are in your third years or in your second years, and if you have your interviews and if you have your interviews coming up, or you're preparing for your upcoming interviews for your internships and placements, you can definitely check out a course called Complete Interview Preparation, the link of which is in the chat box, pinned in the chat box, and it is also there in the description of this video as well. So for that purpose, I would request you all to kindly check out that course. Okay. So now tell me, what will be the base case? Naikach, Vaibhav, Rishit, Abhijit. Yeah. So when you reach step 0, return 1. Okay. So will that be enough? When you reach step 0, return 1. Okay. What about if n is equal to 1? Then if you are trying to call n minus 2, in that case 1 minus 2 is equal to minus 1. So this will definitely be give you a very grave error you don't want, right? So if index is equal to 0, which means you have reached the last index, you return 1. Okay, so return 1. So basically it has a one step. Okay, now also if index is equal to 1, then also you return 1, because once you're standing at one index, you only have one way to reach here. Okay, because from 0 only you can reach here. Got it? So this 2 will be exactly. We don't have to check that condition, that is step becomes 0 then return step becomes negative then return 0. We don't want it. We can just write it in this fashion. If index is equal to 0, return 1, and if index is equal to 1 also, then also return 1. Because if you're standing at 1, there is only one way you could have reached 1, and that is through 0. And if you're standing at 0, it means that means you have successfully reached that position. Okay, so once index 1 is being reached, this recursion won't be called. Okay. So this is a brute force recursion. Now tell me a time complexity for this recursion. Can anyone tell a time complexity for this recursion? So this is the code. Can anyone tell me the time complexity of this recursion? Let's say there are a total of n stairs, and so what will be the time complexity? Anyone? Hmm. The time complexity. So I see quite a lot of healthy audience at this point of time. Do you all want this session at 9 p.m. or 10 p.m.? Which one is more suitable for you? Because last time Rishit was saying that um, the 10 p.m. works very good for him. Yeah, Rishit, we are having a time complexity. Yeah, it will be an exponential time complexity. For every index, we have two possible cases. So we are basically, if we try to find a recursion, it will be around 2 to the power n. Okay, so can anyone tell me, did you observe that this particular problem is also very similar to the Fibonacci number problem? Can anyone tell me how exactly it is similar to the Fibonacci number problem? Yes, Akshay, I am able to listen to you. Yeah. So, Akshay, tell me, do you have any questions? Akshay, I hope you can hear me. So, we are solving a question called climbing stairs, and we are presently having a dynamic programming session. And this session will continue for the next 2 or 3 weeks, because dynamic programming is extremely important from interview point of views. So, since this is the first session, we are starting it easy, and from the next session onwards, we'll try to pick up difficult questions. So, Akshay, do you have any doubts? Okay, so now okay, Akshat, in that case, you have to try to think a lot, because logic building is a thinking process. The more you spend time thinking on a problem, the better logic you are building. And it will only come through time only, because you have to give time. So, if you are presently not able to not able to form logic in your mind, it means that either you have not given a lot of time to think on that problem, or you're, yeah. So that could be the only reason. So try to give a lot of time, and it is not something that you can develop within 1 or 2 weeks or 1 month or 2 months. You have to give a time for long, for example 7 to 8 months. Okay, keep consistently practicing for 7 to 8 months. Like, it depends on other conditions as well, like how good you are with your mathematics concepts, and how are your problem solving skills. So students who have a good grasp over maths and problem solving skills, they develop the logic very very quickly, and those who do not, they require a longer time. Okay. Certainly, in my case, I do not have a personally I personally do not have a great problem solving skills from my math skills, so I had to spend quite a lot of time to grasp the concepts. But I see my other friends who are very very smart and they can quickly develop logic very quickly. Okay, so it depends upon the person. Okay, so yeah, so now it's time to optimize this code, and we will try to store all the recursive answers that we are calculating. So what we will do here is that, hmm, yeah. So let us say I can do something like this. When I just I can either memorize a DP or I can write a tabulation from something like this. So let's say I write a vector int and I write a DP. The DP will be of size n minus 1, and I will initially put it minus 1. Okay, all the values to be minus 1. And dp of 0 is the base case, so dp of 0 is equal to 1 and dp of 1 is also equal to 1. Now I will start from int I is equal to 2, I is less than equal to, let's say, n, and I plus plus. And finally, what will I do? I will write dp of I is equal to dp of I minus 1 plus dp of I minus 2. Okay, so finally, after this is done, my answer will be stored in dp of n. Okay, so since it is linearly storing everything, so this is a one-dimensional DP problem, and the time complexity will be big O of n, and the space complexity will be also big O of n, because we are using a DP space. Can we do it in space complexity O of n? O of 1? Can we do it in constant space? Can anyone tell me? White screen with black pen, please. Okay, let's see. Hello, Crazy Borish. Okay, yeah. So can anyone tell me way to do, since I'm taking a linear space complexity, I'm taking a DP array as well. Can we optimize it further and take no space at well as all? So let's take black pen. Yeah. So now uh, we want to we want to make the space complexity constant. How we will do this? Anyone any idea? Just save the results for n minus 1 and n minus 2. Exactly, Rishit. So this is exactly what we will do. So instead of storing them in the array, we can just store them in two variables, because we only need the previous two values instead of all the values. Okay. So in that case, we will just store the previous two values and we are done. Okay. So the question will be something like this. Just a minute. Yeah. So basically, what we will do, we will keep two variables. Let's say p and q. So p will be 1 and q will also be 1, and we are starting our loop from q to n. Okay. And what we are doing, basically, we are writing let's say a value called cur, which is basically p plus q. Okay. Now once we are done with this, we are just making p is equal to, let's say, q, and q is equal to, let's say, cur. Okay, so this is the optimization that we can do. This is basically a constant space. Space complexity is constant. Okay, so I hope you guys have understood it. Okay, so let's move to a much better problem now. Okay. Yeah, so let's move to a much better problem. So let us move to the problem of longest common substring and longest common subsequence. Okay, I hope everyone knows about this problem. Longest common substring, LCS, and basically longest common subsequence and longest common substring. So LCS is called for longest common subsequence. Okay, so first we will do subsequence and then we will do substring. Okay, so tell me longest common subsequence, what exactly it is and how we will solve it. Yeah, most optimal solution for has O of n time and O of 1 space, right? Yes, exactly, Rishit. But the concept is just same. It was just to show you that in various ways the implementation of DP can be. Okay, so yeah. So all the students who are there in the stream right now, I would request you all to kindly like the streaming session and at the same time subscribe to our channel. So presently at Geeks for Geeks, we are planning to provide you all with great quality content on this very channel itself. So we are having this series, and apart from that, we are also having another problem of the days are also displayed here. We also conduct mock interviews on Saturdays as well. So in that case, but the mock interview has been paused for some time. Okay. So let us do longest common subsequence. So what exactly is longest common subsequence is that, yeah. So first let us get the definition of subsequence correctly. So let's say we have a string called geeks. So a subsequence can be any sequence in this particular string by deleting any of the characters. For example, I can write GKS to be the subsequence of this particular string. Okay, so like we have a lot of geeks, GEEKS. So I'm just deleting ENE, and which is giving me GKS. This is a substring, and I can also delete, let's say, GNE. So my substring will become EKS. Subsequence will become EKS. Mind it, we are dealing with subsequence right now. But the most important point here is that every subsequence, all the characters in the subsequence should be in the same order in the original string. Okay, so this is subsequence. Now, basically, we have to find the longest common subsequence. So let us say we have a problem called, hmm, hmm. let's say we have a string S1. So S1 is equal to, let's say, A, D, E, A, D, E, B, C. Okay, and we also have string S2. So S2 is equal to DCA, DB. So DCA, DCA, DB. Okay. So what will happen here is that we are trying to deal with S1 and S2. Hmm. So we can try to find this string called A, D, B. It is common. First of all, we have to make sure that this is the subsequence for both the strings. Okay, so this is a subsequence for both S1 and S2. And at the same time, it is the longest. So I can see A, I can see D, I can see B. I can also see A, I can also see D, I can also see B. So this is a subsequence that is contained in both S1 and S2. So thereby it is a common subsequence. And at the same time, it happens to be the longest as well. So that will be our answer. So in the question, you're given two strings, S1 and S2, and you have to find the length of the longest common subsequence. How will you do it? So, yeah, as I told, the first approach would be to write a brute force recursion. Okay. So, any ideas how we'll try to solve this question? Rishit, any ideas how we'll try to solve this question? Razi Borish? So, let us continue with the question then. Okay, yeah. So what exactly we'll try to do here is that we'll try to model a function that will basically um, hmm. so let's say I'm trying to write a function which accepts two indexes, let's say index 1 and index 2. So index 1 and index 2 are basically the indexes of string s1 and s2 respectively. So let's say this is s1 and let us say this is s2. So what I'm doing, the size of s2 is n and the size of s1 is n and the size of s2 is m. Okay. So basically what we can do here is that yeah. So let's say initially we send this particular index of n and index of m to this particular string. So now we will check that whether the particular characters are equal or not. So if s1 of int1 is equal to s of s2 of int2. So if both the characters are equal, it means that it is a part of the common subsequence. So what will I do? I will just return 1 because yeah, 1 is a C subsequence, and I will also write the function f of int minus 1 comma int minus 2. Okay, this is done. Now, if let's say they are not common, so in that case, what will happen? I will return this value. Since it is not common, I'm skipping that element, so I'm writing 0. Plus, now what I'm doing here, I'm writing two values: index minus 1 comma int 2, and another value of index 1 comma index 2 minus 1. So now I will take a maximum of these two values. Okay, why I am taking a maximum of these two values? So let's say that these two characters are not common. So it may happen this particular character become common to any of the character from here. Okay, so in that case, that particular orientation will also give us the longest common subsequence. So that is the reason I am taking max of both the recursion. So whichever will give you a maximum value, you will consider that particular answer. Okay, so in this case, it is just plain and simple. If they are equal, you include them in your subsequence and then you continue with the rest. Okay, because if they are equal, it means that it has to be a part of the subsequence. Okay, right? Because it is subsequence. So, yeah. So, can I please have a +1 in the chat, those who have understood the concept of subsequence? Yeah, try every subsequence S1 and check if it is an S2. Yes, pick the largest one that is common. Yeah. So basically, we are trying to formulate a recursive solution for this. So we start from the indexes and we check character by character. Okay. So yeah. So character by character checking, and if they're equal, we increase the length by one and recursively call for the next characters. And if it is not, we just skip that particular character, and then we proceed to the next particular character, which can be possible, and take the max out of both the possible conditions. Okay. So this is the idea that we are using to solve this question. So the time complexity, since this is a brute force recursion, the time complexity will be exponential, which is basically 2 power n. So we want to reduce the time complexity. So how we will do it? Hmm. Anyone, any idea how we will try to reduce this time complexity? Anyone? Yes, exactly. We will try to memorize this particular recursion and then we can proceed further. So let's try to have a look into the code part of its implementation. So instead of writing the code, what I can do here is that I can just put up a snippet for the code, which will be understood for you all. Give me just a minute. I'm just procuring the code, and then I will explain it to you very quickly. Let me include a text box here. And okay, I can increase the size of the text box. So let's see. Can I increase the length also? Yeah. This is the part. Okay. Let's see then. Okay. So first of all, what exactly do we have here? We have a function called LCS utility function. So in this function, what is happening? This is a utility function. This is accepting two string s1 and s2 because we want to do our operation here. It is also accepting two indexes n1 and n2 as I just described, and we are also giving a DP table. So initially, this particular DP table has been filled with -1. So what exactly are we checking first? The first step is to check that whether if s1 of the index 1 is equal to the s2 of index 2, in that case I will store this particular value in my DP table corresponding to this particular position n1 and n2 because the recursion is been having two parameters n1 and n2. Okay, so 1 plus this value, and after that what will I do? If not, then in that case I will just take a maximum of these two values. So once I'm sending index 2 minus 1, and the next time I'm sending index 1 minus 1. Keep a maximum of these two values in this particular position. And then finally what will I do? I'm storing the values. So now the case is to check that whether there are base cases or not. So the base case will be that if index 1 is less than 0 and index 2 is also less than 0, in that case I will return 0 because it means that we have completely finished our string. So if any one of the string is completed, it means that we can stop there and we can just put up 0. And if we have particularly stored the value previously, we can just return it from here. Okay, so initially what are we sending? Initially we are sending s1, s2, and m dp. Okay, so yeah, I hope this makes sense to everyone here. Yeah. So n minus one, m minus one is the index number because we are following zero based indexing. So that is done. Okay. So can I please have a plus one in the chat box? Hmm. So can I please have a plus one in the chat box if you have properly understood this concept? Yeah. Okay. Yeah. Thank you, Anik Mandal. Yeah. Welcome. Okay. Let us keep our session till here. I would request all of you all to kindly revise the tabulation approach for this problem. Also do how to print the longest common subsequence and at the same time learn about longest common substring as well. So these are given to you as your homework. So definitely try to look up this problem and solve this question on GFG platform. Can we take a dry run on string ACB and ACBB? Okay, Rishit, let's do it. Okay, ACB, ACBB. Okay, let me write it here. A Yeah, ACB and ACBB. Okay, so initially let's say n is equal to 3 and m is equal to 4. So we are initially sending the value 2 comma 3 because this is index number 2 and this is index number 3. So once we see that both the values are same, so in that case now we are calling the function. So now our answer is basically 1 plus this is being recursively called for these two variables. Okay, now what will happen? These two are not equal. So now the recursion tree will split into two parts. So once this has been called, after that what is happening? We have one, right? So now we got C and B. So we'll try to call this. Let's say we will try to call f of this value is equal to 1, and then we will try to call so they're equal. So 2 comma 3 are equal. So in that case, we are trying to call this function f of 1 comma 2. Now 1 comma 2 are not equal. So 1 comma 2 will try to call this value. It will either call 1 comma 1 or it will either call f of 0 comma 2. Okay. So so it is standing here, but since it can either call 1 comma 1 or it can call 1 comma 2, and it will take a maximum of these two values. So now once we are at 1 comma 1, so this is 0 1 and this is 0 1. So 1 comma 1 is again not equal. So in that case again it will call for both the values. For example, in this case it will call 1 comma 0 and it will call 0 comma 1, or in fact now 0 comma 2. So this is 0 and this is 2. So we again these are not equal. So in this case it will try to call minus 1 comma 2 or 0 comma 1. So minus 1 basically this will return 0 and this will again try to call something. Okay, so we got ACB and then we got C and then we got basically ACBB, right? ACBB. Okay, I just wrote a mistake here. ACBB. So for this particular we will have one call, and we can also have for this particular we will have one call, and this particular we will have one call. So ACB will be the actual answer. So the answer will be 3. Okay. So I hope you understood it. That why just only at this position only we will be calling differently, and once we are able to get this position, that is 1 comma 1. So this particular 1 comma 1 are basically same, right? Yeah. Okay, so there is slight mistake here. Since 1 comma 1 is same, in that case what we are doing basically, this will call 0 comma 0 and the answer will be 1 plus 0 comma 0. Okay, so and 0 comma 0 is again same, so it will again return 1 plus f of minus 1 comma minus 1, which is basically 0. So 1 plus 0 is 1, so this will return 1. So 1 plus 1 is equal to 2, this will return 2 to this called function, which is 2 plus 1 equal to 3. So finally it will return 3. So your answer will be equal to 3. Okay. And the rest of the recursion 3 are will be not important because they are not leading us to a good solution. Got it? Thank you, Rishit, very much. Okay, so let us pause our session till here. Okay, and yeah, I would request you all to kindly study subsequence part, tabulation part, and substring part as well. Okay, so see you all tomorrow. And I once again would like to thank all of you all to join this for joining this session. Apart from that, if you're preparing for your interviews, you can definitely check out the course called Complete Interview Preparation, which is in the link of which is in the pinned comment and at the same time and in the description as well. It is an extremely well crafted course for preparing for interviews. Okay, so yeah, and do like this session and particularly subscribe to our channel because we are preparing great quality content that we would like to deliver to you all. Okay, so yeah, bye bye, have a good night, see you tomorrow. Thank you very much.